First, first of all, I'd like to thank you for being here for today's session. And we'll be starting, first of all, we'll be starting with, I'd like to tell, isn't listening, please? Okay, I'd like you to mute your mics if you're not muted. Okay, so first of all, I'd like to introduce the organization that the community that we have created last week. It is named as Voice of Code. So the purpose of this community is to help people blog. This community is for MSPs as well as non-MSPs. So the community is basically being run by the MSPs. It was founded by me and Nancy Verma. The purpose of this community is to help people to blog technical blog in the sorry write blogs that are related to the field of computer science and and what is the aim of this community is to provide technical articles, a place where people can refer to for learning and can get resources easily from here. So I'll be attaching a registration form as well for those who want to register up for the and be a part of this community. I'll be also sharing the Medium publication that we have created, and we'll be starting with our articles from Wednesday onwards, and you'll see a lot of interesting stuff coming up. So get connected to it and start following the page. I'll I will just add the link to the publication and the registration form somewhere else. Okay. So Akshita, can you present the slide? Akshita.
Yes, got it.
Okay, go to the next one.
Yes, yes, just a second. Just give me 1 second.
Yeah. Okay, so I'll just start with the introduction that what we'll be covering up in this session today. First of all, we'll start with how to install Python in your PC or your laptop or your device, whatever you are using for programming. We'll start with that. Then we'll move on to a basic hands-on session for how to code in Python. I'll be helping you out with the syntax and stuff. Then Anush will be coming in and he'll be telling about, or he'll be giving a he'll be giving a hands-on experience for a web scraper using Beautiful Soap. He'll be also telling us about something about Python execution thing. Is my voice clear? Just making sure.
Yes, it is. It is
Okay.
audible.
Okay. So after that, we'll be moving on to what machine learning is and what AI is. I'll be explaining that part, and then in the end, we'll be moving on to what regression is, and how to code regression. So this will be a fun ride. for the session today, and I hope you all enjoy. Thank you and learn a lot. Thank you.
Thank you so much, Adil, for introducing the whole session to everyone. And hello, everyone. I'm Akshita Sharma, an MSP from India, Bangalore, and I'll be presenting the slide with the starting part of the presentation, which is Introduction to Python. So let's get started. What's our agenda for today? Today, my agenda would be we'll be discovering together what actually Python is, what are the important features of Python, and what's the history of Python and why it was named Python. Then we'll be moving on to the scope of Python and why do people actually use Python. Then we'll learn how to install the IDLE of Python and who uses Python today. What can we do with Python, and how do we finally we look into the part where we run a sample code on Python and we look on how the execution takes place in Python. Let's get started.
Akshita, you want to talk about?
Hello? Am I audible?
Yes, Akshita, you're audible. Please go on.
Okay. So let's get started with what is Python. They say Python is a general purpose programming language which is applied in scripting roles. It is also a programming language as well as a scripting language, and it is also called as an interpreted language. Well, this gets confusing. So let's look into why Python is called a high-level general purpose programming language. Because when code is automatically compiled, it is compiled to a bytecode and then it's executed. Python is suitable for use as a scripting language, web application implementation language, and so on. Because Python can also be extended as C and C++. Python can provide a speed needed to even compute intensive tasks. Because of the strong structuring constructs such as nested code blocks, functions, classes, modules, and packages, it is consistent use of objects and object-oriented programming. Python enables us to write clear logical applications for small and large tasks. Now we know what Python is, let's look into the important features of Python. What are the important features of Python? Built-in high-level data types. Well, built-in high-level data types like strings, lists, dictionaries, and so on. The usual control structures are also included in it, like if else, if else, while, plus a powerful selection iterator, that's for. Multiple levels of organizational structure. Functions, classes, modules, and packages. These are system organizing code and excellent and a large example in the Python standard library. We can also compile on the fly to bytecode. Like a source code is compiled to a bytecode without a separate compile step. Like when we have used around C and C++, we have to first compile the program and then we execute the program. Here we have a line by line compilation procedure in Python. It is an object-oriented language. Why is Python called an object-oriented programming language? Because Python provides a consistent way to use objects. Everything is an object, and in Python it is easy to implement new objects type called classes in object-oriented programming languages. Well, in programming, not forgetting, almost everything is an object in Python, and simple object definition like data hiding by agreement, multiple inheritance, interfaces by convention, and polymorphism. It has extensions in C and C++. Extension modules and extension types can be written by hand. There are also tools that helps with us this example, like we can use swig, zip, and pyrex. Then we have, why is Python called a dynamic programming language? Well, I personally recommend Python to anyone who wants to start programming with, because Python is it's a user-friendly language, and it's dynamic because there are bound to values and not to variables. Functions and method lookup is done at runtime, and values are inspectable. This is also interactive interpreter, more than one in fact. You can just list the methods supported by any given object. It is highly structured. Python has like statements, functions, classes, modules, and packages that enables us to write a very large, well-structured applications. Why structures? Because of readability, localability, and modifiability. Well, Python is not the only programming language. It has varieties in it. There are huge variety in Python. We can say C Python, JPython, JPython, PyPy, Stackless Python, Iron Python, Python 3, Python 2.x, and so on. Because Python was discovered in the late 1980s. Let's move on to the history of Python. Well, Python was invented by in Netherlands by Guido van Rossum. It was conceived by him in the late 1980s, and it was finally put into implementation on December 1989. This is something which started as a hobby, and it turned out to be a huge open source project. Well, how is it open source? It is open source from the beginning. Why was it named Python? It was named Python because the creator of Python, was a huge fan of Monty Python's Flying Circus. It was his favorite TV show back in the Netherlands. Hence, he named it Python. Okay, let's move on to the scope of Python and why do people use Python? Well, the creator of Python said, my original motivation for creating Python was the perceived need for a higher level programming language in the Amoeba project, which is an operating system. I realized that the development of system administration utilities in C was taking too long. Moreover, doing these things in the Brown shell wouldn't work for a variety of reasons. So there was a need for a language that would bridge the gap between C and shell, and hence Python came into existence. Well, Python has a huge scope. Python is used each and everywhere. We have Python in science, say bioinformatics. In system administration, we have in Unix, WebLogic, and WebSphere. In web application development, we have Jython servlets and CGI and testing scripts. Why do people use Python? Well, I can say that based on my own experience, and the speakers too would be saying this, because Python is an object-oriented programming language. This structure supports a huge concept such as polymorphism, operation overloading, and multiple inheritance. Indentation. Well, indentation was the greatest feature in Python. It is an open source project. It's free of cost. Downloading and installing Python is free and so easy, and the source code is so easily available. It is a powerful, portable, and mixable. How is it powerful? It has a dynamic type. It is dynamic in typing, built-in tools and types, library utilities, third-party utilities such as numeric, NumPy, SciPy, automatic memory management. We can go on. How is it portable? As long as we have compatible Python interpreter installed, the Python programs will run in exactly the same manner, irrespective of the platform we execute them in. It runs virtually in every major platform used today. Mixable. Python can be linked to components written in other languages such as C and C++ very easily. We've seen that in extensions. Linking to fast compiled code is useful in computationally intensive problems. Python or C integration is quite common. Well, it's easy to use, easy to learn. How's it easy to use? No intermediate compile and link steps such as in C and C++. We need to compile and then execute. We don't have to do that. It is just a line-by-line execution in Python. Python programs are compiled automatically and they are converted to a bytecode which the interpreter then reads. This gives Python the development speed of an interpreter without the performance loss inherent in purely interpreted programming language. It is easy to learn because structure and syntax are pretty intuitive and very easy to grasp. Let's move on to installing Python. Well, Python is it comes pre-installed in few of the operating systems like Unix, Linux, and macOS. But when it comes to Windows, which most of the population uses these days, we don't have Python already installed. So we go down to this original site of Python by www.python.org.com, and we go to the download section. here. Here in the download section, we can click on that and we can select the Python we want to use. Okay. Then after you're done with Python, the latest version of Python has come out on April 18 or April 20. It was Python 3.8.2, and you can download that as well as, but I downloaded around 3.6 before. And once you follow the installation process and give all the access to the Python, once you're done with the installation, you go down to the start menu and you see a screen something similar to this. You get Python in your start menu, same Python. I have installed that Python 3.6, so I get 3.6, but you'll get Python 3.8. And then you'll have this IDLE. You have to just open it and then we'll be good to go. So let's move on to who uses Python today. Well, Python is being applied in real revenue generating by real companies such as Google. It makes extensive use of Python in its web search systems and employs Python's creator. Intel, Cisco, Hewlett Package, and so on use Python for hardware testing. ESRI uses Python as an end-user customization tool for its popular GSI mapping products, and the YouTube video sharing service is largely written in Python. Well, let's move on to what can we do with Python. We can do a lot of stuff in Python. Python, we can use it for system programming, graphical user interface, internet scripting, content integration, database programming, gaming, and images, robots, and so on. Okay, let's move on to the execution and how a sample code is executed. We'll have indentation. A block structure is indicated by indentation, and we'll have the first assignment to a variable that creates it. Variable types don't need to be declared in Python. Python figures out the variable type on its own. We'll be seeing it now. In Python, the assignment operator is an equal to and a comparison operator is a double equal to, and the rest symbols like addition, subtraction, multiplication, division, and the mod stays the same. Well, logical operators such as and or a not are not symbols. They're the words, and the basic print command would be print. Well, let's look down to the execution of Python. Okay, I would just want to know if you all could see my screen.
Yeah, yes, your screen is.
Okay, like you can see my screen now.
Yes, I do.
Okay, so we'll start like a simple execution in Python. How do we start any programming language? The first thing we print is print hello world. So we'll print hello world first, and okay. It's a line by line execution. We get hello world right here. Let's try 2 plus 3. We cannot do this in C and C++ or Java, any programming language, but in Python, we just like simply give 2 plus 3 and we get the result as 5. I said before, we don't need to declare the variables in int, like we don't have to say int x. We can just say x is equal to 2 and it'll understand it's an int, and we can just say x, it'll print the value of x, which is 2. So, okay. Well, I hope you all got this. Okay. So we'll see how a code is run in Python. Well, a code of the Python execution code is really simple. Python's traditional runtime execution model, which is the source code, is first, when we type down the code, it's translated to bytecode, which is then run by the Python virtual machine, the PVM, and the code is automatically compiled, but then it is interpreted. So this is the complete execution, and it's really simple to understand, and it's pretty nice. Well, we've executed these few statements. We can execute them again and print hello world. We get the answer as hello world. 2 plus 3 we get as 5, and we give x as a value of array, and when we give the print function for x, we get 1, 2, 3. Well, I hope if you guys have any doubts, you can put it in the chat section below. Anyone has any doubts? If you don't, let's move on to our next speaker. That's Anush. And Anush, it's all over to you now.
Thank you, Akshita. I'll start sharing my screen. Is my screen visible?
Yes, it is.
Okay. So first off, when you write your Python files in a script mode, you have a file. You write your just say if I want to print hello world, and I click run, or I go I manually type Python 3 and then file name hello.py and I run it. I run it and I get the output. So this is simple. But then have you, any one of you have wondered like what happens, like how Python understands that your code which you write, processes it and gives you output. So what happens in the back of the screen? So I'm going to take you through on a brief view on what happens after you type the command python 3 hello.py. So once you pass this command, a workflow similar to this takes place. So you type this command python 3 hello.py in your terminal, and immediately the Python which it checks that whether if a .pyc file exists. What is a .pyc file? When you first execute your file gets compiled, and a .pyc file, a bytecode, is created. So first step, what it does is it will check if a pyc file is existing or not. If it doesn't exist, it will compile the file and it will create a hello.pyc file, which will be visible to you even when you go and check your directory. Next, it will pass your bytecode to the Python virtual machine. So what is the Python virtual machine? A Python virtual machine is a controlled environment in an ecosystem, and your ecosystem is the OS. Imagine a hospital and an ICU ward. An ICU ward is the Python virtual machine, and your hospital is the OS. Your OS, the purpose of OS, purpose of the hospital is to treat people, right? And even ICU does the same. But what an ICU does is that it gives extra functionality to the hospital. So an ICU ward is a treatment place with extra functionality. That's exactly what a PVM does. A PVM cannot do its work without the support of OS. The PVM and the OS together parses your code, creates code objects, executes your code. So only with the cooperation of both the OS and the PVM, you get your output. So your PVM is like an ICU ward, which runs inside an hospital. So your PVM runs inside an OS, giving extra functionality to the OS. So you can have an OS, you can run a program with the help of your OS without a PVM. But without PVM, with PVM, you can't run it without OS. So you need a OS in order to facilitate PVM. So this is a PVM is a very huge topic, and hopefully I'll be giving on more sessions on that. For now, a PVM is with the help of an OS converts a bytecode into machine learn code, and then it gives you the output. Okay, so if a PVC file already exists in your system, we will check if the machine will check if the PVC file if the .python file has been modified recently. Why so? like you have compiled it yesterday and then you did some changes today and you want to run it. So your file, your code would have obviously changed a bit, right? So we need to check whether your file has been changed recently. So we do it with the help of the timestamp. So we check the timestamp, and if the machine finds that the Python file has been modified, it will compile the file again, and then it will pass it to the and it will create a bytecode file. It will replace the existing .pyc file with a new file, and then it will pass it to the Python virtual machine, and the process takes place. In case there has been no modification, then it directly goes to the Python virtual machine. The bytecode goes to the Python virtual machine, and then you get the output. So all you have to remember is that a Python virtual machine adds functionality to an OS, and it helps in giving you the output. Thank you. So can I call Adil to continue for his part?
Just give me a minute. I'm just, just give me a minute. I'm just setting my internet connection so I can talk. Okay, so before we start, I'd like to know how many of you know Python, or how many of you know some part of coding. I'd like to know in the comment chat box. Okay, so I'll start with the basic syntax and all. Okay, so the first program that we'll be working on is a very simple one that I have written, and it's quite famous, and I will many of you might know it. Okay, so we'll be working. So this program consists of three triangles, right? But we'll be working with one triangle right now. I'll be showing you how to create a right triangle and I'll be explaining the syntax to you during the code that I write. Okay, so I enter one. It asks for the height. I enter 5, and here we have the triangle. So we'll be coding this part of the code, and I'll be explaining you how things work here as well. Okay, I hope that I'm audible. If I'm not, please tell me through the chat. Okay, so first of all, as many of you might have been working in different languages. For personally me, I have been working in C and C++. So there's a concept of main functions, right? In Python, you can also work in global functions as well. But what is recommended is that you work in a main function. So first, I'll start how to create a main function. It's very simple. First, you define the function using the thread. Okay, if you have Python installed in your if you have Python already installed with you, and you have Visual Studio Code, I recommend you to open your Visual Studio Code and work with me, so you have a better learning experience. First, we'll define a function, right? So this goes with this. We start with def and we name the function. Right now, I'm naming it main. We hit semicolon. Okay. So now, for example, if I write over here print hello world. Now, if I run this code right now, if you have experiences from previous languages, you might think that the function will run, right. But over here, it won't. There won't be an output you can see over here. But if I print over here outside the function, print ABC, now the output will be ABC, as you can see over here. So in Python, what we have to do is basically first we need to define the main function. We need to tell the interpreter that the function that we have declared is a main function. So what we do is simply we write main here and we hit this. Okay, so basically over here you have to write the name of the function that you have declared as main. Now, after this, when I run the code, it will show hello world. Now, I have defined my main function. So whatever I write over here or whatever function I call inside this function, inside this main function, it will be displayed as an output, right? So if I make changes to it, if I print a plus b, sorry, plus 3, right? So it will give me 5. Perfect. So yeah. Okay. I want to tell you one more thing before we start with the code. Those who have been working with previous languages, right? When we input any element, for example, if you want to input an integer, like I want to make sure that if I enter 5, it counts as an integer, right? When we take an input in C or C++, the by default, whatever data type we keep, we can get in the whatever data type you want, we can take it as an input. But in Python, it's different. I'll show you how to input it first, and then we'll get on with it. Okay. For those who don't know about Python, I would like you to guess what the input will, what the data type will be, right? So if I write enter integer, okay. Now if I run it, right, I enter 5. Sorry, I enter 5. Okay, so I have read 5, right? I'm not printing it right now. First of all, I'd like to know what would the data type be if I input 5, right? So you can just have like guesses here. If I input 5, what should the data type be? What will I receive? Will I receive a string? Will I receive an integer? What will I receive? So you can tell in the comments. Okay, I guess I'll just wait a second so that people start listening. Okay, okay, so guys, you are right now chatting. The chats are visible to the people as well, the participants who are seeing this. Okay, I guess I'll just tell you what will be the output, right? So if I enter 5, right, I want it to be a data type for integer. But if I check the type of the value that I'm receiving uh, from the input, what will it be? Now let's see. I hit 5 and I get a string. This tells me that the data I'm entering is a string. Now, how would I convert it to an integer? If I need an integer, I just simply typecast it to an integer. Sorry. Yeah, now I will hit 5. Sorry. Just a second. Okay, what I'll do is I'll typecast it here. Right. Okay, so here, look, I see that the data has been converted to int. There's one more thing that I'd like to show you. So those who don't know about typecasting, we can basically convert any data type that we want from a high which has lower number of memory bytes to higher number of memory bytes. What I mean is that, for example, string occupies 2 bytes for a data, right? An integer requires 4 bytes. So I can go from string to integer, but I can't go from integer to string. If I go, the issue will be that there will be a data loss. So to prevent from that, I should never try going from a data type which has more memory to a data type which has lesser memory. Now we start with the code for right triangle, right? So I'll start with it now. First of all, we need to take an input of what the height should be for the triangle. So I hit input, enter. I'll go with this. And then now we'll go with okay. Now the logic behind the right triangle is, I think many of you will be knowing it. I'll let you that question will be fine. Okay, so the concept behind a right triangle is we'll be using nested for loops. So I guess most of you are coders here. I think I'm not even sure. Just give me a second. Just give me a second. I'm having a bad network. Okay, it's fine now. Okay, so now what I'll do is I'll write the code. I'll start with, I have the height. Let me convert it to integer first. So the best thing that I like about Visual Studio is that when I hit for loop, if I don't remember the syntax, I just have to hit for the code expression. I'll show it again. I write for, and I'll write for code snippet for loop. Here I have. So I'll write the iterator here. For example, if I want I as an iterator, I'll just remove this and I'll have this. Then I'll write the range that I want. So the range will be from 0 to 5 height, that the height that I want to print. Now I'll write the code that I want. So we'll be using nested for loop here. So I'll just go again and I'll use J. 0 to I plus 1. Now in Python, the thing is that whenever we use print statements, the output goes to the next line whenever we print, right? There's a backslash. It's by default, so we can change it if we want, and I'll be changing it here for now. I'll show you how we can change it. So I'll just print a star, and I'll come over here and I'll say n equals to, I don't want anything right now, and I'll get out of this for loop. And because I want to go on the next line, I'll just print this. I hope that there are no issues with the code. Okay, unexpected intent. Okay, just perfect. Some issue. Okay, there's a 4 0. Okay, so basically it's not going to the next one. Let me just. Okay, I get it. Okay, so the main important thing over here is indentation. You need to take care of indentation. If you miss out proper indentation, the code will cause problem for you. Just let me check the problem. Now it should work. Okay, I'll enter the height. Yeah, so you can see the code is ready. We are running the function through the main function over here, and this was how we'll be using for loop. Now, I hope if you have any questions, you can just tell me in the chat box before I move to the second code, and that will be the last code. I'll be moving to objects and stuff. So I'll just look if there are any questions right now. Okay, I hope there aren't any questions. I just want to make sure if my screen is visible because some people are
Yes,
having
Adil, it is
problem with
visible.
this. Okay, so you can see the Visual Studio Code right perfectly. I'll
Yes, we
just
can.
make it a bit better so that you can see. Okay. Okay, so the codes that I'm writing, you can find it on GitHub. I'll be sharing the link to the repository soon, and I have uploaded the codes and the files on the repo. I'll be sharing it soon. Okay, so I'll now work with classes. Okay, so many or as we discussed about operating system that Akshita told that we can make operating system or sorry object-oriented programming is also supported in Python. So I'll just write a small code for making a class and how to declare objects. So this is an obj. Okay. Okay. So in Python, if I write like this function named init. So with this. I'll just open the code that I have already. Okay, so the function that you see over here that says define in it. So basically, this function is a small this function is a constructor that you have been using in C or C++ or any other language. So when I run this code, what it will do is simply call in the constructor. So I'll just run it right now. Okay. All right. No problems. Now I'll run it. Okay, inspector argument. Okay, sorry. What what I'll do is uh, ab.x. I'll print the value of x right now. Yeah, I'll print the value of x right now. Okay, so you have been working in other languages. There's a concept of private variables, private data members, protected public, right? So by default, all classes in Python are public. You can make data members, data variables, or functions private by adding two underscore. Like if I add two underscore with x, so now it should show me an error when I run the code that there is no x available. Look, so print AVX, this shows me an error that I don't have an object name. Sorry, I don't have an attribute in the object named X. So basically, I have made this private. Now, what self does here? Self will basically tell the function or tell the class that the attribute that I'm trying to access or the values that I'm trying to access are part of the current object that I'm standing on. You might have heard of a concept as this operator in different languages. Here, that points to the current object. Self is doing the same thing. It's basically telling the interpreter that I want to change the value of the current object that I'm pointing to. So yeah, this is it. This now the different concepts that we have in other languages about def. Okay, I think I haven't shown you about the if syntax. I'll just show complete with that, and I will be moving on with the beautiful web splitting. Okay. Now with if, I'll go with again if else code snippet that I told you. It's very useful in Visual Studio Code, and I personally like it. Now you can play around with arithmetic operators as well. For example, now I'll just make a function here. Def check. Okay. And I'll just okay. So basically, I'll just print input a value over here. AB equals to int input enter value. Now I'll go with the if else syntax, right? I'll write just a small code. Now, if AB is equals to 1, right? So if AB equals to 1, it should print good morning. And if now else if, okay, we'll use elif here. There's nothing. If AB equals to hello world, else print have a nice sleep. I'll be just showing you I'll be just showing you the use of or and AND over here as well. Okay, I'll use or AB equals to 3. I'll use AND over here. And AB equals to 4. Yeah, so this is the syntax that is used for if and also. Now, if I want to access this function, I just call it here. I'll just look into it. Now, I'll just call AB. AB dot will be calling check. Basically, now like I'm having a problem right over here, so I can just go over here in problems and see what is it. It says invalid syntax. Okay, just let me have a look. Why is it showing that? Maybe just let me change the name. Okay, yeah, I have to compare it right now. I was assigning it. Yes, yeah. So now they're asking me. Okay, I think we might have just missed it report. I'm sorry for the inconvenience. I have. Okay. Why is this giving me this error? Too many arguments. What is this? Yeah, think the error is with me. So I just right now declared outside the class there's some sort of technical issue. Now I'll run it. Okay, now I enter value 4 and let's see what the output is. Okay, so why is this different? Okay. Here I'll enter 3 here. First, good morning. I'll enter 2. Have a nice sleep. Okay. This is strange. Okay, okay. So basically the problem is with and, right? I have to write it or it's not will work. Or else it won't because for and both conditions need to be true. Okay. And here it go. Okay, just let me see. Yeah, so it's working fine now. I hope that I the syntax and all was very helpful that I helped you with the coding and stuff. I'll be moving on to Anush. Anush, can you take it to become the lead now?
Yep. So I'll take it from here. Once you stop, okay. So I'll be for the next few minutes. I'm gonna walk you through on how to web scraping Wikipedia page. So web scraping, isn't that name pretty self-explanatory? Like you're gonna scrape the data from the website. So this session is about machine learning, right? So and machine learning needs a quality data set, a data. The world runs on data. So we need a quality data set. In order for your machine learning model to have a great accuracy, you need a trustable, a reliable data set, which is unbiased. So as like for most of us, we can personally go and collect the data. I don't think it is possible because the collection of data, a primary source data, is huge expense, and an individual developer like you and me is like at most of the time we cannot afford it. So we have to depend on data providers like Google, Amazon, Windows, and stuff, and depend on the APIs, or we could use their websites to scrape the data off. So we use a technique called web scraping to get the data displayed in their web page into our and save it in a form which we want, a CSV file or an XML or any whatever format we wanted to save, a JSON format or something like that. So so how do you do it, and why do I want to bring web scraping topic in this Python session? Python with in respect to a web scraping technique is ridiculously fast. A lot of software which we use for web scraping is written in Python. Okay, so I'll start my PPT. I hope you are able to see my screen.
Yes, Anush, we can.
So we need a good quality data set in order to train our machine learning models well. So we could use web scraping to scrape these data from the websites from quality providers. But then, isn't that like stealing? Like we are taking data from a website without even informing the person. So the web scraping is kind of debatable. It's a bit of a gray area. A lot of websites allow web scraping on them, and a lot of people don't. And there are ways through which they prevent this. So just be sure that the website which you're going to scrape is not particularly banning anyone from scraping this data. And then we have web scraping softwares like WebHarvey and a couple of more like Outwit, Hub, and Visual Web Ripper, which does this work for you. You can either code a Python program just for it, or you can turn into these pre-coded softwares which you could use to scrape data. And practical uses. You can use web scraping is a tool by which you can collect data. So anywhere where you require data, be it for market research analysis, like you have a company and you have a product A, and there are other companies like company B and company C having similar products. So you want to keep an eye on them. So you web scrape their websites and always keep an eye on the prices they fix for their products and the type of like the features they provide. So it helps in market research analysis. It helps you in personal research or scientific research, and it just gives you it just allows you to take data from sources which you rely on. Okay, so is web scraping the only way through which you can get data from? I don't think so. There's one more thing called API. An API is an application. Hello, am I audible?
Yes,
Yes,
Anush, you're audible. You're
sure.
great. Go ahead.
So you can use an API to get data. And how do I do it? Basically, API is provided by the web developer himself to allow you to use this function. A API can be used to give a functionality for your software to get data from the web owner who's ready to share his data with you. So what do I need to know before I start using an API? I will be covering that too. An access key for an API is like a password, a passcode, which helps you connect into their into their database, something like that. So the reason why they have the passkey system is that they like some companies just give it out for free. For example, the COVID API is free for all; anyone can use and get real-time data on it. But then some providers have limits on them, like around 10,000 to 20,000 calls. On that aspect, a web scraping method is a very effective way to get data, because API has certain limitations to it. Yeah, like at many cases, an API may not even be available to you to use. So you could request your connection to an API provider, and then get you can send data. You can request them, and they can give you data back. So I will start with the hands-on part. I will walk you through the code which I used, which I'm going to do a web scraping part. Okay. So before beginning with the scraping part, I want you to give a good look at the website at which we're going to scrape. So I'll open the web scraping Wikipedia page and analyze the page first. That's the first step which you're gonna do. First, you want to decide which part of the data you want to analyze. See, your normal Control C, Control V, copy paste is an example for web scraping. But then for 2 lines, for 10 lines, say for 100 lines, you can do Control C, Control V. But then, if you're going to plan to copy and paste hundreds and millions of data or GBs of data, you might want to rethink your procedure and try to move on to a web scraping software to do that, automate it for you. Okay, so if I see the website here, it is pretty standard. It is HTML, a pretty standard one. So your Chrome, by the way, I'm on a Chrome browser. So a Chrome browser allows you to inspect the code behind it. So when I click the inspect option, I will be able to see the HTML code which they have used to develop this page. And this option right here, can you see this? A small arrow option. If I click it and if I place it on it, I'll be getting the tags that they use. So before I inspect, I would like to see which data I want to scrape. So, okay. So let me target this. So I want to target this box right over here and get these headings, the titles of the titles available here, and scrape these things. So first thing I need to do is that I need to check what class it belongs to. So you need to have some basic HTML knowledge in order to understand what's happening here. Fear not, you can just try it out. It works on almost all websites, but then having a good HTML knowledge can really help you in a effective scraping part. Okay, so if I place my mouse over here, I can see that there is a span.to TOC text. So it belongs to a class TOC text. And if I place to the other headings over here, the links, I can see a similar pattern here. So I need to target this particular class in order to get the list items. Okay, first I need to request the you have to connect to this page, right? Okay, so now I know what I'm going to target. So I want to get these data from it. So I will go back to the code. I'm using 2 modules here, a request module, which will help you connecting to the website, send request, and a beautiful soup 4. So BS4 is its name. It helps in, it makes your process more easier. I would say import these 2 libraries. I don't think they are available pre-existing in the when you download Python. So you can always use this command to download it, pip4, pip3, install request or install BS4. Since I have it, I'm not going to install it again. So I have imported the file. Now I need to make a request to the website. So I will go here, copy the link, and then I'll come back here, and I'll type the command res. Res is a variable, so I type this request dot get, and in quotes I give my link. Okay, so let's see, like, so if I print res now, I can see like I have around 200 response 200. That means that the connection has been successfully done. So okay, so now my connection is successful. So let me go and see if I am able to get the HTML code through this. And if I run it, I'm going to get a huge list. And I need to filter these these output which I got. So I need to filter it even more. So till now all is good. So let's go on, keep working on it.
Anush, we have
Yeah.
a small question for you in the chat section.
Yeah.
It says, will you cover the web scraping with Scapy or Selenium?
I'm not doing the software right now since our focus is only on Python. So I'll be covering only the part where I through coding we scrape it.
Okay, go on.
Okay. So okay, so now let me continue. Let me comment this. You use an hash symbol to comment so that it doesn't get executed. Now we need, once the request is done, we need, and we saved it in a request object, which is the res. Now I can convert it into a beautiful soup object. And how do I do it? I do it like this: soup, which is a variable again, bs4 dot beautiful soup dot txt. And then here you can give you any format which one you can use, either html.parser or you can I want to use xmlx. Okay, so the beautiful soup function takes two parameters, so just keep it in mind. Okay, so one is a request and the other one is the html parser or an lxml, the format which you want the output to be in. So soup dot select. So I use this command to target the class. So I can write a class, like, let's see here, if I go back to the web page, the class of the history is, the class is to see text, toc text. So I can aim this particular class, and how do I do it is that I use the soup dot select command, and I write this dot toc text. Okay, so if I print it now, if I print this now, right, I'm going to get something like this. And just clear the screen for you. So if I execute it here, my print statement, okay, soup is not defined. Okay, a small typo. Just give me a second. Um, oh, sorry, I have to pass the subject. just give me a second. Okay. So I type the rs.txt, which I pass the res object here, the connection one, and I mentioned it as an LXML format. So, um, so when I print the type of the soup, I'll get my output as the soup is an beautiful soup object. Okay. So now I want to get the links along. So if I just print the soup object here, I'm going to get something like this. Let me extend it for you. Okay. So again, this is like too much data, unwanted data, which I have here. So I need to filter it more. So I'm going to loop through these this soup and just select the tags which the class, the object, the text which has the two sec. So if you notice it here, all these are text, right? So I'm just going to select these words alone out of the data. And how do I do it? I loop it through the soup. So first I write soup dot. So I select the text. So the for loop. Actually, this is not pretty much needed. So for every I in soup.select, I'm asking them to select the 2C text, the class, and then I print it out. So when I print when it goes to loop, it gets refined and you get something like this. Okay, so isn't it what we wanted in the first place? We have the name and we have every single headings from this page. If you can check, we have the history, we have the technique, we have the human copy. If you can come again. So this is how you scrape data from a web page. One way is to use a web. You can write this program and get the details, but then you need to understand how the developer works here, and you need to know a bit of HTML to scrape it effectively. So next, I will use I will give an example of using Air Vision API through which you can get a real-time air quality data. Okay, so let me go and visit the Air Vision is an API provider. He gives you have to log into this website. So I will be attaching this link in the file, and you'll be able to access it through Adil's repository once he makes it available for the people. So your once you log into
I
it,
have made it available.
okay, great, thank you, Adil. So once you log into it, it is pretty much like this. So I used it for one of my hackathon projects, and it is pretty good. So there's an option called API. So the thing with the API is that you need to create a key to access it. At least for this API, that's how it is. So I make a new key, an access key. So I set a plan. A community plan is free here. You get 10,000 calls per month, which is pretty neat. And then you get to access the data which they provide. So a new key is generated. I suggest you guys have your own key, because like I will be resetting it. But then this is a key part here. So first go through the documentation. I strongly recommend you check the documentation before you work onto it. It has the codes which you need to execute it. So pretty much your work is nothing here. So it's like you can get the codes for any type of language which you want, be it Java or be it Python. So I use Python, and the module I use it through request. Okay, so read through their basics, and I want to get the data, like the air quality data in my city, right? So they provide an option through which you can get the data of your nearest city through geo IP location. Now, if I copy this link over here, go to my web browser and paste it here, and then come back, copy my key, come back here, and instead of the your API key, I replace it with my key. Incorrect API key. Sure. Okay, I'll come back to it. If I'm able to do that, I should be able to get the data available. So since the code is already pre available here, I'll just go on and select it, copy the data from here, So I copy the code, I go back to my editor. So now I need to attach my key over here. I can either use concatenation or something similar, or I can use a variable, whatever way, I'll just paste it here. Okay. Going back to my key. Invalid URL. Let me see. Okay, so the problem with the API is that if they update their API is very less focused by a company, so they often update their links and they just forget to update the documentation. So I wanted to show you this part. So the new current, often your own compiler will show you the current available key. So available link. So I have updated my link. So my problem should be pretty much solved now. So if I run this now, okay. Let me see. Okay, cool. So if you can look closely, I'm from Chennai, so it has correctly located my city, and my state is Tamil Nadu, and my country is India, and it has given my location. So if you can see it gives you the weather report and it returns you the data. So like this is the one which I have been looking for. My program has actually returned me the current air quality data from my city. So it has correctly identified that I'm from my city is Chennai using my geo IP location, and it has given me data. So these are the two ways by which you can scrape data from the internet. There are other ways, but then, this is more widely used. Web scraping is more reliable than an API because often companies don't spend much resources in updating and keeping the API up to date. But some companies do. A lot of companies do. So always be sure to just verify your links and stuff. And the thing is that with scraping, it gives you an anonymous, like you don't need to register yourself before getting access to the data. But an API requires you to do, and you have only pretty limited calls, which service provider can limit. So they expect you to buy subscriptions to it. And that's pretty much it. I hope you found it useful. Thank you. Adil?
Yeah, just give me a minute. I'm uploading my slides. Okay, so now we'll be moving to machine learning part. Uh, just give me a minute so that I can upload the slides. Okay. Okay, so if you all like the part about the syntax and the web scraping, share your reviews with us in the comment section and help us improve for future as well. So now I'll be starting with machine learning. Okay, so just to have a normal idea, if you guys can tell how many of you know about what artificial intelligence is. I'm waiting for your comments. If you could just tell me. Okay, okay, so I want this to be an interactive session. So guys, just answer the questions as well, so that we can have an interactive and a fun session. I'll move on right now. Okay. So yeah, so what is artificial intelligence? First of all, I'll start with a basic intro about how artificial came up. So basically, many people confuse the first project of artificial intelligence with a checker project that was made by Christopher Starchy and Dietrich Prince. And there's also one more chess program that is also confused with being the first program that was written by Alan Turing. I hope you all know about Alan Turing, who he is. So basically, these guys started off with writing a checker program and a chess program, uh, where the chess program or the checker program will analyze the current status of the game and will give the outputs. These were very start of the these were very starting programs. But they weren't really artificial intelligence, but they gave the idea and they brought in the idea of artificial intelligence and how machine can learn artificial intelligence. So the first considered artificial intelligence program was written by Newell and Simon in 1955. Although at that time it wasn't named as artificial intelligence, it was just a program which can help prove mathematical theorems as well. So basically what they wanted was to have a program which can solve mathematical theorems and that could interact with people. Okay, not showing in display. Is the PPT visible to the rest of
Yes,
you?
the PPT is visible. Aditya, you can just check up with the internet connection again, please.
Aditya, just join in again. There might be an issue with some teams. Just leave and join in again. Okay. So I'll move on. Okay, it's visible now. Okay. So now the first person who coined the term as artificial intelligence was John McCarthy. He coined it in 1956, right? So now what he had a speech where he coined this term. Now, what does artificial intelligence actually mean? So first, I would like you all to give your own definition. I have already displayed it right now, but I want you all to know what concept you have about AI. Okay, I'll just move on. If anyone wants to tell, they can tell in the chat. So basically, artificial intelligence is a program that is written to interact or develop. That is okay. Okay, perfect. So artificial intelligence is basically a program that is written or that is programmed to perform human-like behavior, right? So now there is a funny thing, and there are a lot of movies filmed on it as well. That they say that AI will be dominating the world in one day. So let me clear up this misconception as well. So basically, there's one thing that most people don't notice it at all, right? If the intellect of the human brain is like that. If we create some problem, we have the intelligence as well to resolve or get rid of that problem. So hopefully, if something like this happens in the future, I hope it won't. But if it will, hopefully we will cope up with it, right? So basically, artificial intelligence is a program written to have human-like behavior. Okay, so now there are three types of artificial intelligence, out of which we have only able to achieve one type of artificial intelligence, that is artificial narrow intelligence or weak AI. Okay, so this form of intelligence is basically a simple program written to carry out a single task. Now, many people, for example, there is a face recognition system. Uh, there are different self-driving cars. There are voice recognition systems like Siri, Cortana, Alexa, and Google Voice, and a lot of them. Drone robots. Okay, so how many of you think that Sophia, right? So about the Sophia robot that was created by Hand Technologies, many people consider it that this type of robot is not in the field of artificial narrow intelligence. They confuse it with artificial general intelligence. But what the scientists have, what the artificial intelligence engineers and experts have said, that it comes in a field of narrow intelligence because it has a purpose only to communicate with people and express certain emotions. It does not, it cannot think like human, or it cannot properly behave like human, right? So now I'll be telling you what artificial general intelligence is. Artificial general intelligence is basically known as strong AI. So this type of intelligence is like the robot or the the program behaves almost or same like a human brain, and it works exactly the same. And this is the thing that you should be scared of if there's some threat for robots in future, right? So you should keep track of it as well. So yeah, I was just joking. So yeah, so this type of so this is what people confuse Sophia with, that it's an AGI, but it's not an AGI. It's an ANI. We haven't been able to achieve AGI, but there are many people working in AGI and trying to achieve it. But it's a very difficult task for us as human beings to achieve it. And hopefully somewhere near 2030 or 2040, around 10 to 20 years within that, we might be able to achieve that. Let's hope for it. There is one more type of intelligence that is known as artificial intelligence, that is known as artificial super intelligence. So now, what is artificial superintelligence? Basically, it is the intelligence where the program or the robot will be showing uh, sorry extra intelligence or extra behaviors more than human. So it will be more intelligent than human. But I personally believe that this might not be possible in future. Let's see what happens. Anything can happen, but yeah, there I think it might not be possible because there are some, everything has a limitation, right? If we can't think, whatever we can think, we can create. I personally believe that, right? So if we can't think about intelligence, super intelligence, we can uh, create it as an AI baby. Okay, Aditya, can you just explain a bit more about your question? I'll just answer that. If you are talking about what AI as an infant is, okay, so type it on. I'll just tell you what it is. Now I'll be moving to machine learning. Now, what machine learning is? Machine learning is basically a field that has been derived from artificial intelligence itself. It was okay. So this was the field. Okay. Okay, now what is basically machine learning, right? It is a field where computers are given the ability to learn without being explicitly programmed. You'll understand when I further explain what supervised learning is, what unsupervised learning is, and what reinforcement learning is. Basically, here we provide, for machine learning, we provide an environment for the artificial intelligence to train itself based on the data sets that we get. So you will be, when you'll be coding no, AI like a real baby. I don't think you can say that. But when we train AI, right? If you are training artificial narrow intelligence, or if you are training artificial general intelligence as well, what we do is we think of it as the artificial intelligence as an infant, right? We train it as an infant first, right? For example, if like when you're a child, you don't know what color is what, which color is which. You don't know what is red, what is green. So you are taught what is red, what is green, right? So it's the same with AI. When you create a normal AI, even a narrow intelligence, even a facial recognition system, you might have seen in Facebook, or you might have seen it somewhere else as well. So basically, in those types of systems, what we do is we first tell the artificial intelligence that this person is, for example, if I have my DP uploaded on Facebook, first I'll tell the intelligence that this DP is Adil Asif's profile picture, or this is Anush's profile picture, and the artificial intelligence will understand that picture, and it will show labels of that picture in future as well. So now you might have seen when the feature was new in Facebook, they told you to like tag people on the pictures. Now when there is a picture popped up of someone else, or you upload a group photo, It might just show up suggestions that this is this guy or this is that guy. So that's how artificial intelligence is being trained. I'll be having a full-fledged talk on only artificial intelligence soon enough. I'll invite you to that as well so you can uh, learn more about it. Yeah. So I hope I was clear enough. Okay, so yeah, machine learning. Okay, so I was telling you that we provide a specific environment to a machine and we give them a proper data set where they work, where they learn themselves. They teach what is, they teach about what they learn about what thing is what. Like we are provide, for example, like when technology was new, like when mobile came up, we didn't know what mobile is. We were just given a mobile and we learned it by ourselves. We learned the computer use of computer by ourselves. So we are just given an environment that we have to learn by ourselves. So machine learning is doing exactly the same thing. We give them the data, we give them the environment, and we tell them to learn on their own. Now I'll be moving on to types of machine learning. First is supervised machine learning. So in supervised machine learning, I hope you're able to see the diagrams. If not, I'll just be explaining the diagrams. You can see it on later on. I have shared the Git repo, right? So you can check it from there as
The
well.
diagrams are visible, Adil.
Okay. Okay, just give me a minute. Yeah. So supervised learning. What happens in supervised learning is basically you first of all you have coded the program. You have written the program. Now you give it a data set. Now the data set consists of both input data values and output data values. Now you train now what happens is for a specific input there is a specific output. For example, like this. Give me a minute. Yeah, for example, a spam filtering or spam email filtering. What first we'll do is we'll give an input, we'll give certain emails, and we'll tell the program that, for example, email A is a spam, email B is not a spam, and so on. We'll give them a variety of input and output data sets. The machine learning, the algorithm will learn on the data set and will map every input and output onto each other. After that, what it will do is it will create it. It will go into an iterative process where we'll give it an input. Now we'll only be giving it an input, and based on the model, based on the learning, whatever the algorithm has created, the algorithm will check what the input depends, whether it's a spam email or whether it's not a spam email in this case, right? So now what will happen is when we give the input for a new data value, it checks if there's, for example, it says in the first try that it's not a spam email, but we know that it's a spam email. We tell the algorithm to work again on the solution and recheck it. So until and unless the algorithm doesn't come close enough to the output that we are expecting, or perfectly comes to an output that we are expecting. It is in an iterative process until it reaches the preferred output. Now, what's the benefit of this? Can you guys just, if anyone knows the benefit, can you just tell it in the chat and I'll just look into it. I'll tell the benefits from my side as well. Okay. So basically, the benefit of this algorithm is like it's an iterative program, right? So regression model that we'll be creating, that Akshita will be telling you about, will be will is a part of supervised learning, right? So you will learn a lot from that also. The advantage of this type of processing is that the algorithm learns from a data set. It has an input and it has an output, so it maps it and it learns on it until and unless it doesn't have a preferred output, right? So it learns on it, and whenever we want, like as the algorithm progresses, the accuracy of the algorithm increases, right? So that's the benefit of this iterative process. That Okay. Now, I hope there are no questions with this. I'll be moving on. Okay, now what is unsupervised learning? In unsupervised learning, the training data that we give is just the input data. Now, for example, we are just sending in the pictures, right? Sorry, we are sending in data like I send in different. objects. Like first of all, I send in t-shirts. I The second input data that I'll give is fruits. The third input data I'll be giving it is tables, right? Tables as in such the hardware tables. Okay, so these are the input sets that I'll be giving them. Now, what the algorithm will do is the algorithm will identify and detect what type of objects is it getting, and it will cluster them into different sets. It will make a specific set of all the t-shirts. It will make a specific set of all the fruits. It will make a specific set of all the tables, right? And it will identify and understand what type of data is it getting, and it will detect on itself. Now, what happens with this type of learning is that uh, these types after it has learned what data is what, we give it a new data, it processes on that data, and then it produces an preferred output. For example, if I'm giving it a t-shirt, right, as a new input, and I want to identify what is it, right? So what I'll do is that I'll give it a t-shirt and I'll ask the algorithm to process it and tell me what is it, and it will tell me that it belongs to this specific data set, and it's this data this type of t-shirt. So what now, where is this used? It is used in robotics, as I told mentioned about Sophia before, right? So about Sophia, it can mimic human behavior very well and emotions, right? So it might also be that unsupervised learning as well, right, where it mimics human behavior. It is mostly used in robotics and anomaly detections. Now, how in anomaly detection? For example, there are different problems going on. I'll take an example of a supermarket, right? Uh, Now, what we have done is we have provided it the data that these are specific things that will be happening. Like I have given a temperature range, normal range. I have given it data about what fire is and different sort of data, right? So whenever, sorry, just give me a second. Okay, so whenever it will learn on that data set, and whenever it will see that something is related to, for example, fire, so it will just pop up the alarm, or however it is programmed to show that it will detect that this problem is going on, and this sort of emergency protocols need to be initiated. So this was about unsupervised learning. Now we'll be moving to reinforcement learning. Okay, now what reinforcement learning is? Okay, so basically about reinforcement learning, it is a potentially complex environment. Now, what happens in this is basically there's an agent. For example, in this condition, if I'm programming the code, right, I'm the agent, and the algorithm will be working with me. I'll set up some policies, and for example, in a checker game, right, I'll tell the algorithms that these are certain rules, these are certain boundaries. Now, what the algorithm will do is it will carry out a trial and error process. It will make certain moves, it will lose sometimes, it will win sometimes, it will be learning and staying within the bounds of the policies. Give me a second. Now what the policies will be set by me. I'll tell the algorithm that these are the rewards. These are the these are the rules of the game, and these are you don't have to go out of these rules. You have to follow these rules, right? Now, now there are two types of rewards in this that the algorithm might receive through the trial and error. As I said, it might win a chess game or it might lose a chess game, right? So what happens is that if it wins a chess game, the response is positive, and if it loses a chess game, the response is negative. Now, when it's receiving a negative response, actually it's better for the algorithm. Now, how is that? I'll link it to an actual real life example. For example, just think about it. You are having your midterm exams, or you have having your quizzes in your university, right? So what you will be doing is, for example, I hope it doesn't happen, but if you fail in a midterm exam or in a quiz, what you will do? You will basically prepare more, and you will look up to your mistakes, what mistakes you made, and you will move up. Sorry, you will have more practice, and you will have more learning before you are prepared for the next midterm exam, right? So your efficiency will be increased. You will work more. You will work hard enough to achieve the positive response that you want. Whereas if you have a positive reward, right? Like if you passed in your quizzes and if you passed in your exams, you would think that I haven't done anything wrong, and I hope in majority cases this happens. Is that we continue with the same efficiency, with the same with the same amount of practice that we had in midterm one. We would continue it with midterm two or in our final exam with the same efficiency uh, continued, right? So this happens the same with the algorithm here. What it will do if it has a negative reward, what the algorithm will do is learn on its mistakes, what mistakes it did, and improvise on its mistake in the next phase. Now this helps in improving the efficiency in a longer term. Whereas for the positive reward, it is good. It will be learning. It will be learning from positive rewards as well. But on a long run, it will be having. It won't be that much efficient if it won't face any negative rewards during its learning process. Thank you. I hope I was clear enough, and I hope that you all understood and you had a great learning experience. Now I'll move. Now Akshita will take in place for regression. Thank you.
That was an amazing talk, Adil. And guys, if you have any doubts, you can just type it on the chat section below. Okay, so he's already explained what linear regression is. So I'll be taking up the part of linear regression today with machine learning. Okay, so let's start with linear regression for machine learning using Python. What is linear regression basically? I guess in statistics, linear regression is a linear approach to modeling. It's the relationship between a dependent variable and one or more independent variables. In that case, if where there's one independent variable, it's called a simple linear regression. And for more than one independent variables, the process is called a multiple linear regression. This term for distinct for multivariate linear regression, where multiple correlated dependent variables are predicted rather than a single scalar variable. In linear regression, the relationships are modeled using linear predictor functions whose unknown model parameters are estimated from the data. Such models are called linear models. Most commonly, the conditional mean for responses given to the values and the conditional mean is found out. Okay, so did I mention statistics in the beginning of the definition of linear regression? Yes, I guess I did. So let's check if linear regression is related to statistics. Isn't linear regression from statistics? Well, no, it's not. Linear regression, before we dive into the details of linear regression, you may be asking yourself why we're looking into this algorithm of statistics. Is it a technique from statistics? Well, machine learning, more specifically the field of predictive modeling, is primarily concerned with minimizing the error of a model or making the most accurate predictions possible at the expense of expandability. In applied machine learning, we will borrow, reuse, and steal algorithms from many different fields, including statistics, and then use them towards these ends. As such, linear regression was developed in the field of statistics, and it is studied as a model for understanding the relationship between an input and output numerical variables. But it has been borrowed by machine learning. It is both a statistical algorithm as well as a machine learning algorithm. Types of linear regression. Types of linear regression are, we have various types of linear regression. When we start looking into linear regression, things start getting confusing. The reason is because linear regression has been around for so long, more than 200 years actually. It has been studied from every possible angle, and often each angle has had a new and a different name. Linear regression is a linear model, like a model that assumes a linear relationship between an input variable x and another output variable y. When we plot a graph, we have x and y axis, being x being the independent one and y being the dependent one on the x axis. But when there is a single input variable x, the method is referred to as simple linear regression. When there are multiple input variables, literature from the statistics often refers to the method as multiple linear regression. Different techniques can be used to prepare or train the linear regression equation from data, the most common of which is called ordinary least squares. It is most common to therefore refer to as model prepared. This way as ordinary least square linear regression or just least square linear regression. Now that we know some of these names used to describe linear regression, let's take a closer look at the representation used. Linear regression on model representation. The representation is a linear equation that combines a specific set of input values, x, to the solution which is predicted output for the set of the input values, y. As such, both the input values and the output values are numeric in nature. The linear equation assigns one scale factor to each input column and called the coefficient and represented by a capital Greek letter called beta. One additional coefficient is also added, giving the line an additional degree of freedom, example moving up and down on the two-dimensional plot, and is often called as the intercept or the bias coefficient. For example, in a simple linear regression problem, to a single x and a single y in the form of a model would be y is equal to b0 plus b1 into x. X is the independent variable and y is the dependent one here. In higher dimensions, we have more than one input. The line is called a plane or a hyperplane. The representation, therefore, is a form of equation and the specific values used for coefficient in the above example. It is common to talk about the complexity of a regression model like linear regression. This refers to the number of coefficients used in the model. Okay, linear regression as a learning model. Linear regression as a learning model has four types. There's a simple linear regression, ordinary least squares, also called as the least squares, gradient descent, and the regularization. Let's look into simple linear regression first. So, with simple linear regression, we have a single input. We can use statistics to estimate the coefficient. This requires that we calculate statistical properties in the data such as means, standard deviations, correlations, and covariance. All of the data must be available to traverse and calculate statistics. This is a fun as an exercise in Excel, but not really useful in practice. Ordinary least squares. When we have more than one input, we can use ordinary least squares to estimate the values of coefficient. The ordinary least square procedure seeks to minimize the sum of the squared residuals. This means that a given regression line, through the data, we can calculate the distance from each data point to the regression line, square it, and sum all of the squared errors together. This is the quantity that ordinary least square seeks to minimize. This approach treats the data as a matrix and uses linear algebra operations to estimate the optimal values for the coefficient. This means that all of the data must be available and you must have enough memory to fit the data and perform matrix operations. It is unusual to implement an ordinary least squares yourself. Unless as an exercise in linear algebra, it is more likely that you will have to call a procedure in a linear algebra library. This procedure is very fast to calculate. Moving on to the gradient descent. What's a gradient descent? When there are one or more inputs, you can use as a process of optimizing the values of the coefficients by iteratively minimizing the error of the model on your training data. This operation is called as gradient descent and works by starting with random values with each coefficient. The sum of the squared errors are calculated for each pair of input and output values. Learning rate is used as a scale for factor and the coefficients are updated in the direction towards minimizing the error. This process is repeated until a minimum sum squared error is achieved or no further improvement is possible. When using this method, we must select a learning rate, an alpha, example, parameter that determines the size of the improvement step to take in each iteration of the procedure. Gradient descent is often taught using a linear regression model because it's relatively straightforward to understand. In practice, it is useful when you have a very large data set, either in number of rows or the number of columns that may not fit into the memory. Well, moving on to regularization. Regularization is the extension of the day training of the linear model called regularization model. These seek to both minimize the sum of the squared error of the model on the training data used, using ordinary least squares, but also reduce the complexity of the model, like a number of absolute size of the sum to all coefficient of the model. Two popular examples of regularization procedures are last regression, where ordinary least squares is modified to also minimize the absolute sum of the coefficients, called L1 regularization. Ridge regression, where ordinary least squares is modified and also minimized to the square absolute sum of coefficients, is also known as L2 regularization. These methods are effective to use when they are in collinearity. In your input values, the ordinary least squares would overfit the training data. Now that you know some techniques to learn with the coefficient in the linear regression model, let's look at how we can use this model and make predictions to our new data. Well, making predictions with linear regression. Given a representation is a linear equation, making predictions is as simple as solving the equation for a specific set of inputs. Now, let's make this example. Let's take this example from height versus weight, with height being on the x-axis and weight being on the y-axis. So we have the linear regression common equation, y is equal to b naught plus b1 into x1. Let's replace x and y with the original values, where b naught is the bias coefficient and b1 is the coefficient for the height column. We use a learning technique to find a good set of coefficient values. Once found, we can plug in the different height values to predict the weight. For example, let's use b naught as 0.1 and b1 as 0.5. Let's plug them in and calculate what a weight for a person would be with a height of 182 centimeters. So we take weight as it is, and 0.1 is the b naught coefficient, and we take b2 as b1 as 0.5 and b naught is 0.1, and the height would be 182 centimeters. So we get the final result of our weight as 91.1. So we can see that the above equation could be plotted as a line in two dimensionals also, as shown in this figure. The b naught is our starting point regardless of what the height we have. If we can run through a bunch of heights from 100 to 250 centimeters and plug them to the equation and get the weight, creating our line. Well, it might almost not be accurate always, but it would end up being to the closest nearest value possible, because machine learning does calculate errors too. Preparing data for linear regression. So, first we have linear assumption. Linear regression assumes that the relationship between your data and the output is linear. It does not support anything else. This may be obvious, but it is good to remember when you have a lot of attributes. You may need to transform the data to make a relationship linear. Example, log transformations for an exponential relationship. Remove the noise. Linear regression assumes that your input and output variables are not noisy. Consider using data cleaning operations that let you to better expose and clarify the signals in your data. This is most important for your output data variable, and you want to remove the outliers in your output variable y if possible. Remove collinearity. Linear regression will overfit your data when you have highly correlated input variables, considering calculating pairwise correlations for your input data and removing the most correlated. Gaussian distributions. Linear regression will make more reliable prediction if your input and output variables have a Gaussian distribution. You may get some benefit using transforms like log or boxcars on your variables to make distributions more Gaussian looking. Well, Last but not least, rescale the inputs. Linear regression will often make a reliable prediction if you rescale input variables understanding standardization or normalization. Okay, now we know little enough about this, so let's jump on to the hands-on session. So here today, okay, 1 second. Okay, sorry. Okay, can you all see my screen?
Yeah, your screen is visible.
Okay. So now we'll start coding, like we'll just do a small project on linear regression. On a housing problem, we'll import the data from NumPy and matplotlib and using pandas and sklearn datasets. So let's get started. So here we So here we imported first NumPy, then matplotlib, pandas, and sklearn. And now we know Python is already a line-by-line executor, so it executes statements line by line. That's what happens here. If we have an error, we get the error on the certain line itself, so we don't have to go through the entire code again and again. Okay, there's an error. Model not found. Oh. What's happening? Okay, we got it. So here we load the data from Boston into the variable Boston, and then print the data we have loaded. So here you get the data printed, whatever data has been loaded from the sklearn datasets. Here we'll put down all the data into columns and graphs, like we'll sort it down into columns and rows. Now we load the target as the target data set, which is involved in the Boston thing. Boston data sets we have imported from sklearn. And we can say the axis equal to 1. Axis is up to you guys. You can put the axis as 1 or 2 or anything. And now we'll display the data we have loaded. So we'll load the data here. We can sort the data based on ascending or the descending order. So we can either set it as ascending is equal to false, or we can even write it like ascending is equal to true, or that descending is equal to true. So here we get the data, and we can choose our x and y axis based upon your, it's completely up to your choice. Here I'll take x as target. Okay, let's take x as LSAT. LSTAT. Just make sure you guys do no mistake in noting down the names from here, because even a single mistake it will load into an error. And the y-axis would be the target. Loaded the data, and now let's start forming an array. Okay, we've done that. Now let's give how you want to train the data. Let's sort the data on n. Let's assume n is equal to int of 0.8. 0.8 into the length of, say, x. Okay. Now let's train the data for x. We'll say how much of data we'll be taking from x as well as y. So here we'll be taking 80% of the data from x, and n will be equal to 80% of the data. Test the data. We'll create a different graph. We'll have another graph for testing the data. It'll test 20% of the data because test and train are like test plus train will be equal to 100% of the data which will be there. So okay, it's successful. Now we'll plot it. So we'll data for the train first. So x train, y train. You can say color to be, let's take it as green. You can say color to be anything. See, the data here is plotted in green. So let's plot the data for, plot the graph for the data we have loaded in test. So make it blue instead of green. So V is for blue. So you can see the graphs of the loaded data. Now we'll define hypothesis for these, and then we'll calculate the error and the step gradient. So hypothesis of A, B, say it'll return A star X plus B. Wait a second, okay. A plus B. Yes. Let's define error. A, B, and Y. So we'll have, let's assume error is equal to 0 in the beginning, then m is equal to length of y in of m. The error.
Akshita, just scroll it up so they can see the code.
Okay. Yeah.
The code that you're writing right now.
Oh, okay. Sorry. Visible?
Yes, it's fine now.
Okay. Hypothesis of A x of I will finally return half of or E. Okay. We'll define the step gradient now. A, B, X, and Y, and the learning rate. Calculate the learning rate above, so we'll be using it here. Gradient of A, initialize it to 0. Gradient of B, initialize to 0. And we take M as length of X here. Now for I, increment it by I and Y of I. Right? Now gradient of B, we'll increment that too. We'll take here and X of I and Y of I. Okay. Now we can say A is equal to A minus the gradient of A learning rate. We'll say B is equal, we'll initialize B again to B is equal to minus into B into the learning rate for B. And then A and B. Now we'll calculate the descent for initial data, initial of A, and then initial of B by the learning rate and the iteration. So let's say A is equal to initial of A and B is equal to initial of B. Okay. Now for I in range, for iteration, we'll have E as the error for X and Y. Now if I mod 100, sorry, 1000, compare it to 0. If the answer is equal to 0, when it's divided by 1000, we'll print error as and we'll get here, we'll just put down the errors we'll get. Now A and B will be equal to B, X and Y and the learning rate. Finally, we return A and B. Now let's display the errors we'll get from the learning rates. So let's take value of A is 0 and B is equal to 1. Let's take the learning rate as 0.001. All these values are up to you guys. You can put in any value you want. A is always you can put A is equal to 1, B is equal to 0, but A and the value of A and B cannot cross 1 and 0. The learning rate can be put as 0.0, 0.01, 0.1, 0, any number of value. In the iterations can be, this is number of iterations you need for calculating the error, and the final value of A and B. Final A and B will be 10, B, and the X string X train, Y train, learning rate, and the iteration. Okay. Wait a second, I did a spelling mistake somewhere. Okay.
Akshita, the issues with the input.
The issues with? Oh, okay. Yeah, sorry. No. A initial.
Yeah, the issue is with the input.
Issues with. I'm not getting issues with.
Wait, I think you are correcting.
I just corrected that. Initial. Okay. Okay, yeah, it's working. Spelling mistakes. So we get the answer here. We get the iterations. Second. Okay. So now we print the error. So B Y train. It shows the error. The error is 0.08. I wonder how the error is so less. Print the final error. The error of final A. Train and Y train. Now we plot it. Plot the errors we have received. We'll plot the X and okay, let's plot X and Y. Train and Y train. I'll take up the color red. So here's the error displayed for the, not the error, sorry. This is the plot for your X and Y train data in the above set. We train 20% of the data, sorry, we train 80% of the data for the X and Y, and 20% of it was for the test of the data. So now we'll plot the hypothesis with the final A and B. As for the test data, we've done red enough. Let's take blue. Let's, okay. X for test, and we'll take hypothesis as the y-axis. Hypothesis of final A, final B, and X test. let's do this in green. Okay. Green, why isn't defined? Oh. Okay, here's the final data we get. And if you guys have any doubts, you can just ping us in. We'll be there to solve your doubts. Any doubts in the chat section?
Okay, so I think you had fun analyzing. Is my
Okay.
voice clear?
Yes, it is.
Okay, so now we'll be moving on to the Kahoot session. So Anush, can you start? I'll start thinking.
Yeah, just give me 1 minute.
Yeah,
Let's ping everyone in,
I'll,
whoever
yeah.
have.
You can either use your phone to join or something. You need your screens to see the questions. I wasn't able to change that part, so you need your questions will be displayed here. I'll be sharing my question screen here, and your Kahoot, yeah, just the way we do it normally. Okay.
Anush, can you share your screen? Your screen is
Yeah,
not visible.
yeah, just 1 second. I'm working. So can you guys see my screen?
Yeah.
Okay. 1 minute. Wait. Oh, okay. So we get started.
Uh,
Use the pen and join the session. Thank you.
Okay, just hang on.
Vedant is here.
Yes, Vedant's here.
Hello, Kamal. How are you, man? Bill Gates is here.
We're waiting for Salman told to ping him. He's not here yet. Vedant, can you call Salman?
okay, I'm just having a problem. Anush, can you tell me where to write the code? I see a screen with classic option and
There is an option called join game, and then it will ask you for a code.
just a minute. Okay, it says Kahoot is loading. Okay, found it. Just a correction. The website is kahoot.it.
Should I start?
Yeah. Okay, you can start. I guess. Yeah.
Okay.
Just wait a minute. Just wait for a minute.
So I wait for 1 more minute.
Yeah. Okay, we have to respond.
Okay, I'll start.
Yeah. You're
Which
also
of
doing a
the
voice
following symbol are used for comments in Python? Six got it right. Hash is used for commenting in your Python program. Which keyword is used to define methods in Python? Five got it right. Ferris Rohit is coming on top. Nested if else statements are allowed in Python, so that's the thing to remember. So which of the following are the correct ways to declare a string in Python? Banana reminds me of minions. Six people got it right. Bill Gates is coming to the top. How do you find, what is the predefined Python function that is used to find the length of a string? Len is the function which we use to find a string's length. Ferris is on the first, followed by Bill Gates, Hackerman, and Leaderboard. How do you find the last element of a list in Python? Let's assume the list is named as bytes. We use byte -1 in square brackets. That's how you select elements in a list. Okay, that's quick. 5 people got it right. AJ is also known as deep AI. How many type of machine learning are there currently? leaderboard, stopping the leaderboard. And the last question. And it's regression. And here we come to the end. And let's check the podium out here. The third place goes to Bill Gates. And the second place goes to Rohit. And the first one is bagged by leaderboard himself, followed by Hacker and Mini Leaderboard. Thank you guys for being here. I hope you had a good session out there. We had a nice experience. Thank you for joining us.
Thank you for now.
Thank you guys.
Thank you all for being here for the session. I know it was a long session. Thank you all. I hope you don't have any questions. If you still do have some, you can tell us in the chat. We'll be here for a while.
Thank you all.
Hey, Anush, who was fourth? Anush,
Yeah?
who was fourth?
Huh? Oh yeah,
Fourth?
okay. Well, one. Yeah, but then you. I got a 3. Okay, I'll correct it up.
No, no, I'm saying who was fourth position.
You're asking what's the fourth question is.
No, no, we're talking
He's
about that.
asking who was the runner-up, like the second or the first runner-up.
That hacker.
Oh, okay, that was me.
Thank you so much, everyone, for being here today and
Okay,
staying on till the
I guess.
last.
Yep.
It means a
Thank
lot.
you,
Okay, I guess.
Thank you, Ganesh. Thank you, Vedant. Thank you all. Thank you, Aditya, for
Yes.
being here.
Special thanks to Rohit and Ganesh for helping us out. Thank you. So I guess we'll be ending the call. Anush and Akshita, let's get on the other call right now. Okay.
Yes.
Yes.
Alright.